Now in this unit we'll discuss chapters 8 and 9, and starting with chapter 8 for analysis and design. This is a short chapter and discusses the general considerations for analysis and design of concrete. It helps us define some of the constants we'll use in our following analyses. So lambda we'll define as 1.0 for normal weight concrete, as well as ES, which is the elastic modulus of the steel, and EC, which is the elastic modulus of the concrete. Moving on to chapter 9, generally the strength and serviceability requirements should satisfy some ultimate load is less than or equal to our phi, or our load factor, times our nominal strength. Section 9.2.1 details all the load combinations, and from this we can see that the maximum will be 1.2 times the dead load plus 1.6 times the live load times 1.6 times our earth pressure. And we'll only include the earth pressure in flexure and shear because those are that's a load on the beam. But for the actual bearing, we're checking the cables within the beam bearing on a concrete section of concrete. So we'll take that out. And for hoisting and decking, we'll take the maximum load to be 1.4 times our dead load. And you can see here our load factors of 0.9 for flexure, tension controlled, 0.75 for shear, and 0.6 for bearing. And I'll note that we need to make sure that we check this and confirm that our section is tension controlled after doing the analysis. We'll ignore serviceability design here because unlike in the towers, because the anchor is buried in the ramp, if cracking occurs and the anchor beam deflects a little bit, it will be supported by the ramp fill and overburden. So as long as strength requirements are met, we will consider this sufficient, although cracking in the anchor would not be ideal. So for the loads, it's now time to set these up. And we can start with the easiest, which is H, or active earth pressure. I've drawn a diagram here, and this is a lot of equations, but we can start by defining our active earth pressure as just the P active that we've already found before, transposed into the same coordinate plane as the cable forces, and for this we'll use the average backstay angle. And for a final note, we'll keep all of our loads in kilonewtons to remain consistent, but remember some of the equations from the code are empirical and you need to use the specified units they have in there. So you'll have to transfer those back to those units. I won't go through that whole process here. Now, setting up the dead load and live load cable forces, we'll use the same equations from our cable analysis. But remember to start with a pH from the dead load, or design sag, and the dead load only, or the pH from the live load sag and the live load only when you're looking at these different components. So we won't go through that whole process again in the interest of time, but I will say remember to include the pH tower term as well, and this equation should be the same as what we use in the anchor sliding analysis. And remember not to double count, like I said before, the dead load when you're evaluating the live loads too. The live load, although sometimes referred to as a live load, we're really talking about the total load in a lot of those other sections. And note here too that we'll subtract the overburden weight multiplied by the frictional resistance from the dead load cable forces to account for the fact that the anchor does have some inertial resistance to sliding by the time the load reaches the ramp wall supports. And then in the next sections, we'll calculate our ultimate shear and moment from our combined loadings with a beam length of 2.4 meters. So I'll dive into this equation just a little bit. You can see I have the PT back term, which is the cable loading, plus the pH tower term, that's the ramp walls actually pulling on the anchor, minus the overburden term, and those two are multiplied by that cosine of alpha average in order to get them in the right direction, and that's our dead load. And our live load will be the same PT back term plus the pH tower term from the live load in the right direction. And that using that pH tower term is really conservative. Probably could take that out if we needed to, but like usual, we're going to start broad, and if we need to make refinements, we'll do that in further sections.